Okay, after 30 minutes later. All right, so number 8, and that was page 195. So we had a grocery cart, and we're pushing it. Okay, and it had let's see, the force applied was what? 30 newtons I minus what? 40 newtons J. And the distance was what? Negative 9 meters I minus 3 meters J. Okay. So the work, all right, y'all, we just multiply everything together. Times what? Negative 9. And then what? Negative 40. Negative 3. And this comes out to be 270 joules plus 120 joules. And so the work is what? Negative 150. Okay. So the cart is actually moving which way? It says apply a constant force. All right. So it's moving in the what? Negative direction? Yeah. The work going back the other way. Okay. All right. Mass was what? 1.5. Right? Get it? Did you get it? Okay. Good. All right, that was easy, wasn't it? To me, works a little bit easier than some of the other stuff we've been doing. To me. Now, again, I'm the teacher. I guess I might say that, but I mean, does it seem a little more cut and dry, straightforward? Oh, no comment. Oh, well, okay. Maybe not. All right. Just get through it, right? Okay. All right, let's look at the second part. All right, what about B? B says what? Oh, boy, what does B say? All right, if 0.75 joules of work is done on the book from B to C, how fast is it moving at point C? So we were looking for what? Final velocity? All right, so let's redraw it. Now that was A, right? So let's redraw it. So we got what? We got A, B, and then we got C. All right. So from here to here, the amount of work done was negative 0. What? 75? Yeah. Joules. Okay, y'all, we know that work is equal to delta K, which is equal to 1/2 mv squared final minus 1/2 mv squared initial. So we want to find final velocity. All right, now let me ask you something. The final velocity of A to B becomes the what of B to C, the initial velocity. Did you catch that? So what is my initial velocity right here? 1.25, right? So we want to find final. Right? Now, y'all, I don't care how you work these. I'm not real nitpicky. Some professors, physics professors, they make you work the equation out and show it and then plug it in. And if you don't, they count off on an exam. And I'm not real picky about that, okay? Because I've had them tell me that. But, and again, everybody, okay, whatever you want to do, every teacher's different. So, but I just want you to get it, okay? All right? So, but again, I'm old school. I always like to work it out. So our equation's going to end up looking like this right here, but we got to solve for what? Final velocity, don't we? So how are we going to do that? We're going to add a positive 1/2 mvi to both sides, right? So it looks like this. 1/2 mvi squared plus work is equal to 1/2 mv squared final. Now I want to solve for v final, don't I? So v final is going to be equal to, and this is what my equation is going to look like. The square root of, now watch, 2 in brackets times the work plus 1/2 mv squared over the mass. Right? Solve this equation solve this equation, I'm fixing the screen, that equation right here for that right there. Yes?
For the work, would you take the negative 6.56 and subtract the...
No. No.
Okay.
No.
You would just use
But,
the
yes.
negative 1/7?
That's right, because that's the work that is done from B to C. The previous is the work done from A to B.
Okay.
That's over with. Yeah. And see, it's like Dr. Satelli would say, now the physics, all the physics is done. It's just simple mathematics. We've done all the physics. Now we just got to plug and chug. And honestly, y'all, I really wished you would learn to do that, because in engineering you're going to be doing a lot of that. You're going to have several equations, and you may have to take a couple of equations and plug them together to solve for one. Okay? And again, I know that's a lot of algebra, but you need to train yourself to do that. Okay? Because it helps you to see when you look at these equations, you'll say, oh yeah, that right there is the same as work. Potential energy is the same as work. And kinetic energy is the same as work. And kinetic energy has velocity. So I can find the velocity. Okay. So now we just plug and chug. So the final velocity is what? All right, it's 2 times the negative 0.75, and it all works out, joules, plus, and it's 1/2, and the mass was 1.5 kilograms times 1.25 meters per second squared, all divided by 1.5 kilograms. Final velocity should be what? 0.75? Gummit. Okay, now that was that part of the equation. What would it be if it was plus 0.75? Well, what would it be? Well, it's the same equation, except instead of plugging in negative, you plug in positive. And the answer should be this. 1.6. Now, y'all, I like problems like that. Okay? because it makes you think about the physics and what's going on, the work and what's going on, all the physics. Put it together and solve, okay? That's a good test question right there. 1.6. It's the same equation, you just plug in positive instead of negative. You got it? Oh, I forgot my brackets down here. There we go. Now, number 21 is a similar problem. Similar. Except here we're using gravitational potential energy. And that equation is very simplified because some stuff cancels out.